Good afternoon, everybody. So I'm going to introduce you our first results on the identification and quantification of chlorination byproducts which are formed during in-breast current cathodic protection of wind turbine. So ICCP consists in cathodically polarizing the structure to be protected by an external power source. The intended oxidation reaction on in-breast current anode is oxygen liberation, as we can see. However, another unwanted reaction occurs in presence of chloride that leads to the generation of chlorine. In water, chlorine is quickly transformed into hypochlorous acid. And in seawater, when bromides are present, hypochlorous acid is transformed into hypobromous acid. The next reaction shows that hypobromous acid is a very reactive oxidizing agent, which is able to react with organic matter, natural organic matter or anthropogenic organic matter, to form the misnamed chlorination byproduct, as this chlorination byproduct are mainly brominated byproduct. So by using the Faraday law, it is possible to calculate the amount of chlorine produced by one anode during the polarization phase or during the operational phase. This level is thus around 200 grams per hour during the operational phase, as we can see in this table. Such represent around 40 grams per hour of hypobromous acid. So it seems to be a huge quantity of hypobromous acid generating from one anode. So to simulate what happens to wind farm, we have made cathodic protection with in-breast current close to the real situation. We have designed a protection potential of carbon steel around minus 800 millivolts. That corresponds to a mean current density of 0.080 ampere per square meter. So in order to simulate the ECCP system, we have used 3 steel plates with a total combined surface of 800 square centimeter. A voltmeter was employed to measure potentials on the steel plates. The system was then completed with an inert anode made in titanium, coated with metal mixed oxides, presenting 2 reactive sides and a combined surface of 30 centimeter square centimeter. 15 and 20 milliampere were applied. So we obtain a current density of around 6.6 ampere per square meter, as you can see on the left. Okay. We have used seawater sampled in the Mediterranean Sea close to Marseille, and we have conducted experiments during 7 hours. Samples were regularly made and analyzed by GC-ECD analysis. After here we have the example of different compounds. So we made liquid-liquid extraction with MTBE to eliminate salt before analysis. So we obtain various peaks in as we can see. I will come back to the nature of this compound just afterwards. The next chromatograph shows the analysis of alloacetic acid. It's the same method, but we need an esterification step before analysis of this compound. So here you have the result we obtain. We have determined kinetics of formation of some chlorination byproduct. On the upper side, you have some example of compound we found. So the highest compound found is 3-bromomethanes, correspond to bromoform. Bromoform is the compound generated at the highest concentration and which around 80 micrograms per liter after 7 hours, as you can see on the left. The rate of production was not directly correlated to the level of ampere. We obtained the same results at 6 or 10 ampere per square meter. For dibromoacetonetriol, with a maximum of concentration was around 12 after 7 hours, but as we can see, we do not reach a real plateau at this time. As regards bromolyl weight, it seems that it is a transitory product, as it seems that we have a decrease after 6 hours. These three other compounds are the alloacetic acid we found, so bromochloroacetic acid, dibromoacetic acid, and 3-bromoacetic acid. So here you have a summary of all the compounds we have identified. So 10 compounds have been identified belonging to 5 families. As you can see, the compound form are very different according to their physicochemical properties. Some of them are high to semi-volatile, are cyanogen bromides, dibromochloromethane, bromoform, and 3-bromonitromethane. So these compounds are not supposed to be able to accumulate in water or in organism, but should be. We think that they go that they are volatilized quite quickly. The other compound, and especially alloacetic acid, are not volatile, and these compounds are supposed to be accumulated in water and probably in organisms. Yes, so to resume, we have found 10 compounds belonging to 5 chlorination byproducts. Among these compounds, 5 are volatile or semi-volatile, and 5 are able to be accumulated in the environment. It is important to note that we have unknown compound on our chromatograph. We suppose that the compounds not identified are allophenol, allobenzoquinone compounds, but it needs to conduct further research to find the nature of this other compound. We have tried to extrapolate the production rate of this of the identified compounds. So as you can see, if we applied realistic current density currently applied on a wind farm, we have you can see the production rate of these different compounds. And as I said before, bromoform is the main product able to be generated during ICCP. This experiment have been conducted in aquarium, so it was close to realistic condition, but not real condition. So we now need to sample water in real environments in wind farms, where we can see if these compounds are really present and if they present a risk for the environment. Thank you.